Welcome to the second video on calculating the order of reaction looking at experimental data. So this example is a bit more complicated. So like the first one, we've got 3 experiments here where we've changed the concentration of A and B and then we've measured the initial rate. And by looking at these, we want to calculate the individual orders for A and B and the overall order by adding those two together. So just like the last video, what we're looking for is 2 experiments where one of the concentrations has changed and one of them has stayed the same. So if I look at experiments 1 and 2, we've kept the concentration of A the same, but the concentration of B has changed. So this allows us to work out what the order of B is. So the concentration of B has increased by 2, and when we've done that, the rate's also increased by 2. So because that's the same factor, that means it must be first order for B. So B is first order. Now this is where it gets a bit more complicated, because when I'm trying to work out the concentration of A, so the order of A, I need a line where A has changed but B stayed the same. But we can see from these experiments there isn't a line, there aren't 2 lines where the concentration of B has not changed. So what I need to do is compare 2 of these lines, but also look at the effect of B, because we know the effect of B because we know B's first order. So I'm going to look at lines 2 and 3. So A's changed by 2 and B's changed by 2, and then we can see the effect of that on there. So the easiest thing here, and I've not really left myself space, is to write another experiment in. So we're going to do a hypothetical experiment here where I don't know the effect of A, so I'm going to keep that the same. So we're looking at comparing line 2 here. So I've kept A the same, but I'm going to change B to this 1 here. So when I've done this, A stayed the same, B has gone up by a factor of 2, and we know that B's first order, so if that's gone up by 2, then that rate's going to go up by 2 as well. And this now gives me 2 lines that I can compare. So if I compare line 3 and 4, I've changed the concentration of A, but B stayed the same, which allows me to see the effect on the rate of just changing the concentration of A. Now, I'm going to look this way around because I find it easier to go up rather than down. So if I go from 4 to 3, I've increased the concentration of A by 2, and when I've done that, the rate's gone up by 2. So therefore, A is first order. And then the overall order is the sum of the individual orders so it's just 1 plus 1 equals 2. Okay, thank you for listening. See you next time.